Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. All right. Now, what we're going to do is we're going to focus here on circles. As you can see, the conic sections we're talking about in this video series, there's 4 of them. There's parabolas, circles, ellipses, and hyperbolas. We'll mix in some problem sets, some problems that you can try yourself, and I'll go over those with you, and then we'll finish with a self-quiz. All right, now remember that a conic section can take one of those 4 forms. We've talked about parabolas already in this video series, so you can look for that. Now we're going to focus on circles. Now a circle is where you take a knife edge, or a plane actually, and parallel to the floor and to the base of the cone, you're going to slice right through it. And of course it's going to create an intersection, which is a perfect circle. Well, first of all, let's talk about the equation of a circle. And the general form of that is this: x minus h, the quantity of that is squared, plus y minus k squared equals r squared. Now, it's important to note that the x and the y are the variables in this equation, and the h and the k will be actual numbers, and they'll represent the center of the circle. And the r is going to be the radius of the circle. So if you can identify from this equation form what the h and the k values are, then you'll know where to locate the center of the circle, and you'll know the radius, so you can sketch it out from there once you know the center and the radius. So you're going to locate the h value there. That's going to be the x coordinate of the center, and the k value right there in the formula is going to be the y coordinate of the center. Also, this r value is the radius, as I mentioned, and in the equation it may not be an actual squared number or a perfect square number, so it could be a square root or a radical amount for the radius. So that's something you have to kind of watch. Also, notice that the formula has subtraction signs there. Alright, I'll give you an example of what happens if you see a plus and how you have to adjust the h and the k values. Alright, let's go to the graph and see how to do this. Alright, let's start with a real basic example here, and something that's pretty common is x squared plus y squared equals 1. Alright, well, first of all, notice that the 1 could be written as 1 squared, and so, you know, when you take the square root of that, the radius would have to be 1 unit. So wherever the center is, the circle is going to go out 1 unit in all directions. Also notice that x squared is really x minus 0 squared. Okay, so we need to know that the h value would be 0, and same with the k value, because y is really y minus 0 squared. Alright, so you'd locate the center at 0, 0, and the circle will go out in 1 unit in all 4 directions. So as best as we can, we would draw our circle. And pretty boring, simple circle, but that's the basic idea. Alright, now let's look at something a little more complicated. Here's the equation: x minus 3 quantity squared plus y minus 2 quantity squared equals 16. Well, right away I know that 16 can be written as 4 squared, so of course that means the radius must be 4 units. Alright, that's pretty convenient. And then the h and the k values there following the formula, make sure it's subtract in front of them, and that would be positive 3, positive 2. Okay, pretty easy. So locate the center, 3 on the x-axis, 2 going up from the y, and we're going to go out 4 units this way. Put a little mark there. 4 units straight up, 4 units to the left, and 4 units down, and then we can draw a nice little curve there and get that drawn out. And there it is, circle with radius of 4 and the center located at 3, 2. Alright, let's look at one last more challenging example. All right, x plus 8 squared and plus y minus 5 squared equals 10. There's our equation. We have to graph the circle. Now notice it says plus here in the first group. Well, we need to be thinking about putting that in a subtraction form because that's what it has in the equation form up here, right? And so it's going to be x take away negative 8. And then that 8 has to be negative as our center. So just a little adjustment there. That's going to have to be a negative 8. And then this is still going to be a positive 5. All right, so let's locate the center at negative 8, 5. So we're going to go down 8, or over 8. And up 5. And the center of the circle will be located right there. All right, now what about the radius? Well, it's supposed to be r squared here, and if r squared is 10, then the radius must be the square root of 10, right? It's not a perfect square number. Now think about it. We know that we can take the square root of 9, that would be 3. So the square root of 10 would be a little bit more than that. And it's actually about, that means approximately here, equal to 3.1, 3.2, something like that. All right, so if I kind of round up a little bit, 3.2, we'll just have to guess approximately on this graph. So from that center, we're going to go up, down, left, and right about a little over 3 units. So here's 3 and a little bit more, so I'll just put a little mark right there. This is straight up, 1, 2, 3, a little bit more. Trying to approximate it here. We can go to the left here, 3 units plus a little bit more, and go down 3 units plus a little bit more. All right, let me try to draw the circle. All right, here it is. Let's try to place it correctly and see if we can draw it. And that looks pretty good. All right, that is the graph of our circle. So remember this equation form here. It's going to come in very handy. And look for the very next video in this series, which will be testing your ability here with a problem set. All right, thanks for watching. Take care. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard,